All right, let's take a look at this next question. This is 20 here. So it's 2015. I'll write this in. So 2015, it's the NCEA end of year algebra exam. And this one here is actually an indice question, and it's an indice form, but really, unlike some of the other questions I've recently done for you folks, we have to turn this into log form to make it work. Now, this works on the principle that if you've got a log of a particular variable and it has an index or a power related to it, like let's say, for example, I had the log of, let's say, x to the power of 3, we could rewrite that as 3 log x. In other words, the indice becomes the coefficient of the logarithm. Similarly, you could have, let's say you had log x, and you had, let's say this was 4 log 5, then you would then say that's 5 times 4 is 20, and you've got log x. So the indice becomes the coefficient. If there's already a coefficient, you multiply the indice by the coefficient to be the new coefficient, and so on. All right, well, let's take a look at this one here. Now, this works on this kind of principle. It's got a couple of twists and turns I can see coming up there with that one, actually, especially with the +1. And you'll see that in a moment because that creates a rather interesting coefficient. So here we go. Let's have a shot at it. So I've got, I'm going to run out of room here, I think. So I'll write that again. Anyway, a to the 2x is equal to b x plus 1. And I'm going to find the log of both sides. So I'm going to go log of a to the power of 2x. And you can see what's coming up with the coefficient there. And this is going to be log of b to the x plus 1. Of course, the 2x now becomes the coefficient, as does the x plus 1. So in the next line, I'm going to get 2x log a is equal to x plus 1 log b. Now we have to be careful because it's not x plus 1 log b, it's x plus 1 log b. So I better pop that all in there. It looks like a d, doesn't it? It's a 1 though, yeah? All right, so now what we're going to do is we're going to expand this out a little bit. So I'm going to rewrite this as 2x log a is equal to, I'm going to expand this, x times log b is going to be x log b plus 1 log b, yeah, it's just going to be plus log b. Now, I can actually see a bit of a pattern here, something common here. We've got an x here, we've got an x here. And if I was to subtract x log b from both sides, so I'm going to go subtract x log b. Sorry about writing it like this, because I'm going to run out of room, you see. Subtract x log b. Hope you can see that all right. Then I'm going to, this x log b's vanish from this side. And now we've got, crikey, I'm really going to find some more space here. This is going to be 2x log a minus x log b is equal to log b. Now, what's common here? Oh, x is common. So I could take x outside the brackets here and go x, have some brackets here, equals log b. And inside the brackets, I could say what times x makes 2x log a? Well, that would be 2 log a. And then I could say what times x makes negative x log b? Well, that's going to be negative log b. So I can get x on its own because the question simply says, make x a subject. There it is. Well, let's make x a subject. So all I'm going to do is divide both sides by 2 log a minus log b. Divide 2 log, oh, I didn't put log a there, log a minus log b. 2 log a minus log b. And you could probably put it in brackets, but as long as it's on the lower side of the vinculum, it really doesn't matter too much. So I'm now just going to cross all that out because this divided by this is 1, leaving me with x, and I'll write it over here. But therefore, x is equal to this thing here, which is log b all over 2 log A minus log B. You might be, I suppose, tempted to return the 2 to the A here, making it log A squared minus log B, but I wouldn't. I'd leave it in a more basic form like that. And that would be my solution. Hope that makes sense.